about vectors. The points A, B, and C have position vectors OA. Just use column notation, so -2, 1, 4. OB is, there's no K, so the K component is 0, so we have 5, 2, 0. And for OC, 8, 5, -3. Question is to find the factor equation for L1. So L1 passes through B and C. That means we need a point factor. We can use OB or OC. So we can use the point B or the point C. And for the direction factor, we can use BC or CB. So here we use point B and the factor BC. Now BC is the C minus B. So C minus B, 8 minus 5 is 3, 5 minus 2 is 3, -3 minus 0 is -3. So this is the factor equation. Actually, you can also divide everything by 3 here if you want to simplify. Now, for the line L2, use factor notation again. So 2, 1, 4, -2, 1, 4. Then the direction factor 3, 1, -2. Find the coordinates of the point of intersection. So for intersection of two vectors, we equate the two factor equations. So we have red equals blue, and we analyze each component. So for the x component, 5 plus 3 lambda equals -2 plus 3 mu, and for the y component, 2 plus 3 lambda equals 1 plus mu. Now from the first two equations, we can simply subtract. Here we can substitute or eliminate to find lambda and mu. So if we substitute, we subtract, they cancel out. We have 5 minus 2, -2 minus 1, 3 minus 1. From here we add 3 to both sides and divide both sides by 2. We get the mu. To find the lambda, use one of the equations. If we use this equation, replace the mu with 3, and we simplify and then subtract 2 from both sides, divide both sides by 3, we get lambda. So now we need to check, we have to make sure that when we plug into the third component, 0 minus 3 lambda equals 4 minus 2 mu, we plug in the mu and the lambda, we should get exactly the same thing on both sides. So now it checks. We do have the right values of mu and lambda when they intersect. So question is to find the point of intersection. So we can use the red or the blue factor equation using the lambda and the mu. So if we use the red one or the blue one, it doesn't matter, we will get exactly the same result, which is 7, 4, -2. Alright, now the last part, the point D on L squared such that AB equals BD. So the length AB equals the length BD. Find the position factor of D. So previously we have the point A, the point B, and the line L2. So just start by drawing some kind of graph to visualize things. We have this L2 line, and the point D is on that line, and we have some point A and B. We don't know where they are, but we do know that this distance is the same as this distance. So D, we don't know the coordinates, we can say x, y, z. Since D is on the line L2, we can always replace the x with -2 plus 3 mu from here, and we can replace the y with 1 plus mu and the z with 4 minus 2 mu. Now the factor AB is the coordinates of B minus the coordinates of A. So 5 minus 2, that's 7, 2 minus 1, that's 1, 0 minus 4, minus 4. So this is the factor AB. For the factor BD, it's D minus B. So for D, we use XYZ, but if we use XYZ, we will have 3 unknowns, so just use this form only in one unknown, one variable mu. So this is the coordinates of D minus coordinates of B, which is 5, 2, 0. So this is D minus B. After we simplify, minus 2 minus 5 minus 7, 1 minus 2 minus 1, 4 minus 0, 4. We have this factor and this factor, and we look for the magnitude or the length. So we use like Pythagoras, 7 squared, 1 squared, minus 4 squared, add everything, take the square root. So that's how we find the magnitude. Same thing on the right. Now we square both sides, so we cancel out the square roots. 4 squared, 49, 1, 16. And if we square the right hand side, just write it down like this. For 3u minus 7, we have 9 mu squared minus 2 times 3 times minus 7, so minus 42 mu, plus 7 squared, 49. And from this expansion, we get u squared minus u plus 1. And from this expansion, we have 4u squared minus 16 mu plus 16. And then we simplify. 9 plus 1 plus 4, 14. Minus 42 minus 2 minus 16 minus 60. And from here we get 66. Same as this, also 66, so we can cancel out the 66. And we have only this simple quadratic. Factorize 2 mu. We have this is the same, and this is the same. We're just factorizing here. So after we factorize, we solve, because we have something equals 0. This means 2 mu equals 0, or 7 mu minus 30 equals 0. So in this case we have mu equals 0. In this case we have mu equals 30 over 7. Now if the mu equals 0, the coordinates of D will be, replace the mu with 0, we get minus 2, 1, 4. Which means this is actually the coordinates of A. Now this solution is rejected because the coordinates of D cannot be the same as coordinates of A. If that's the assumption, then we reject this solution. Okay, assuming we have two different points D and A. And if we replace the mu with 30 over 7, use a calculator, we get this. And therefore the coordinates of D, or the position factor of D, is this in IJK form, or you can just leave it in the column factor notation. Alright, I'll see you again.